It is possible to show how light travels by drawing the wavefronts. However, it is very time-consuming to draw each wavefront from a source of light. Instead, we can use a simplified ray diagram to show how light travels through materials. Light rays on a ray diagram are drawn as straight lines that are perpendicular at a 90-degree angle to the wavefronts. The direction of travel is indicated with an arrow. This image shows plane waves interacting with a straight surface in a ripple tank. The crests of the waves have been illuminated using a light source to make them easier to see. In the image, you can see the water wavefronts approaching the reflector and the waves being reflected away from the reflector. This is also how reflection occurs with light waves. When light hits a surface, it can be reflected, absorbed, or transmitted. When light is reflected from a smooth surface, the light will reflect in parallel rays in one direction. This is called specular reflection, and it is how mirrors work. The following ray diagram shows the reflection of light rays from a smooth, shiny surface such as a mirror. Where the incident ray meets the surface, we draw a line at a right angle to the surface, dotted line on the diagram. This line is known as the normal line. The angle between the incident ray and the normal is called the angle of incidence, I, and the angle between the normal and the reflected ray is called the angle of reflection, ER. For a mirror, the angle of incidence equals the angle of reflection. However, if the surface is rough, the light will not reflect in parallel rays, but will scatter. This is called diffuse reflection. The scattering effect can be easily seen by disturbing the smooth surface of water and observing the resulting changes in the reflected image. The incident light rays are reflected off in many directions. This is how most objects appear to the human eye. In the image, the reflection in the water does not form a clear image of the objects like in the mirror. This is because the surface of the water is uneven, and incident rays are reflected in random directions that do not preserve the order of incident rays from the object. A periscope is a simple device that allows you to see over or around obstacles. It works using mirrors to reflect light from the object you want to see to your eyes. Here's how it works. 1. Structure. A periscope is usually a long, narrow tube. At each end of the tube, there is a mirror or a prism set at a 45-degree angle. Second, light path. Light from the object enters the top of the periscope and hits the first mirror. The mirror reflects the light down the tube. At the bottom of the tube, the second mirror reflects the light towards your eyes. 3. Reflection. The mirrors change the direction of the light path by 90 degrees twice, allowing you to see the image of the object that is not directly in your line of sight. By using this simple principle of reflection, periscopes let you look over walls, around corners, or above water if you are in a submarine.